Welcome to my new video. Today we're going to be finally factoring x squared plus bx plus c. And again, this is why I end up sitting in my car. These are the dogs. This is what they do when I am trying to take a video. And then my daughters come in while I'm trying to make a video. It is just a mess here. Alright, let's begin by actually just using the FOIL method to multiply and see if we can see a pattern. So again, I want you to be able to notice patterns to be able to make sense of these problems. So if we have something like x plus a times x plus b, so anything where the two first terms are x's and then we have two numbers or a combination of numbers and variables for the last terms, what happens? So we're going to do our x times x. So our first is x squared, our outer is 3x, our inner is 2x, and our last is 6. And then we combine to get x squared plus 5x plus 6. So first, outer, inner, last. So we have x squared plus 11x plus 30. And one more. This is actually one of those special types, but I'm going to do it the FOIL method. First, outer, inner, last. And then we combine those middle terms. So what I want you to notice, or see if you can notice, is do you see a relationship between our A and our B? So 2 and 5 and our in our middle and last terms. So how does 2 and 3 relate to 5 and 6? How does 2 and 3 relate to 5 and 6? How does 5 and 6 relate to 11 and 30? And how does 5 and 5 relate to 10 and 25? You should see a pattern of how you can manipulate the 2 and the 3 to get the 5 and the 6 to get the 11, and the 5 and the 5 to get the 10. And it's the same pattern. It's that same manipulation or same operation. 2 plus 3 is 5. 5 plus 6 is 11. 5 plus 5 is 10. And what about the last? 2 times 3 is 6, 5 times 6 is 30, and 5 times 5 is 25. So because of this pattern, where you see the last terms added to get the middle term number and multiplied to get the last term number, we can use that idea or that principle to work backwards to actually go from this form to this form. So again, this unit's all about taking it already multiplied all back out and putting it into the factored form, working backwards. So here, if we can split this to two numbers that multiply to 25 but add to 10, we have our answer. So to sum that up, what we're really looking for are two numbers that add to the B and multiply to the C. So two numbers that multiply to 6 and add to 5 are 2 and 3. So that gives us our last terms. And of course the x is our first term because x times x is x squared. So we're looking for two numbers that multiply. So when we do the last, so the first, outer, inner, last, they multiply to the last term of our trinomial, but that the outer and the inner add to our middle term. So we're looking for two numbers that add to this and multiply to this. And those are the two numbers that are going to make up the rest of our binomial. I just love factoring. So to factor this, I'm going to set up my framework. Because my coefficient is 1, I know it's going to be this method. We are going to go on to other methods, just like we did the common binomial and then the special cases. There are different ways to factor, but for this, if you have a trinomial, that has a coefficient of 1 for your leading coefficient, you can see if it works like this. So can you think of two numbers that multiply to 12 because of our last and add to 8 because of our outer and our inner? And I can tell you one huge hint is if you're looking at it for more than about 5 to 10 seconds, you need to start factoring this out. So I have 1 and 12, 2 and 6, 3 and 4. Which one of them add to this middle term? This one right here, positive 2 and a positive 6. Always go back and double check yourself. So we have x squared plus 6x plus 2x, that's 8x, plus 12. That works out, and this is our answer. All right, the next one is a little trickier though, because our product, this part right here, is negative. So what that tells us is one of the numbers has to be negative. So this was a positive 12 up here. Now it's a negative, so I know it has to be, one of the factors has to be negative, like negative 1 and 12 would multiply to a negative 12. But it also could be 1 and negative 12. 2 and negative 6, or negative 2 and 6. 3 and negative 4, or negative 3 and 4. So as long as one of them, and then remember the sum is going to be 4. So which two of these add to 4? Not these two. Here, a positive plus a negative, you subtract, so both of those are 4, but which one leaves us with a positive 4? It would be this one right here. So I'm going to set up my framework, where I know my x is the first term, minus 2 plus 6. And always double check yourself. X times x is x squared, plus 6x minus 2x is my 4x. Negative 2 times 6 is a negative 12. Okay. All right, so part of your assignment is training your brain to think this way, finding those two numbers that multiply to one number but add to another. So I have something I call Snappy Factors, and it's going to help us train our brain to find these numbers. Exercising the brain. So you have 3 different sets. One set is the product is always positive, the sum is always positive. So what does that tell you about those two numbers? It tells you that if the product is positive and the sum is positive, both numbers have to be positive. But for set 2, if the product is positive but the sum is negative, that means it's two numbers added together, and two numbers that are negative added together are negative, but two numbers that are multiplied together that are negative end up positive. And the last set has the product as negative. That means if the product is negative, you have to have one negative and one positive. So again, the first side of your assignment is just finding these numbers. Two numbers that multiply to 36 but add to 12. 6 and 6. 6 plus 6 is 12. 6 times 6 is 36. 18 and 11. 9 and 2. 9 times 2 is 18. 9 plus 2 is 11. And again, if it takes you more than, like I said, 5 to 10 seconds, please start writing out, well, we've already done this one, 6 and 2. Please start writing out the factors. The factors of 15, 1 and 15, 3 and 5. 3 and 5 add to 8, but 1 and 15 add to 16. So you know that those are the two numbers. So don't be afraid or feel like you are going to look stupid if you're actually writing out the factors, because I guarantee it's going to save you time in the end. Okay, so the next one is actually a typo. I found it before I ran the assignment, but not before I made this into a PDF. This is supposed to be a 36. So if you're using the PDF on BB9, it's a 26. It's supposed to be 36. I know this because there are no two numbers that add to 13 and multiply to 36. But if we look at 36 and start, let me change the color again, and start doing our factoring instead of just staring at it, thinking of it in our heads, we have 1 and 36, 3 and 12, 9 and 4, bingo, 9 plus 4 is 13. So my two numbers are 9 and 4. I'm not going to do all of the rest of these for you, but remember, the set 2 is just like set 1, except both of the numbers are negative. So for example, this one right here, 12 and negative 8. It is similar to this one, two numbers that multiply to 12 and add to negative 8. Well, two numbers that multiply to 12, they have to both be negative, because their sum is negative. So we could do negative 12 and negative 1, negative 3 and negative 4, negative 6 and negative 2. The negative 6 and negative 2 add to negative 8. So actually, set 1 and 2 are identical, except set 1 is positive, set 2 is negative. And step 3 is a combination, and you have to remember this with the sum, because 1 is positive and 1 is negative, you're actually going to be subtracting. So let's do a couple of these. Negative 14, the sum is 5. So I have negative 14 and a positive 1, or I could reverse that and have it a positive 14, negative 1. That clearly does not have a sum of 5. So then I go 7 and 2. The difference of them is 5. There's more, since this is positive, I know the bigger number has to be positive. So my two numbers are 7 and negative 2. Let's do one more like this. Negative 40 and negative 3. So now, the first one that I think of with 40 is 8 and 5. Because one of them has to be negative, we're finding the difference. The difference of 8 and 5 is 3, but there's more negatives, so I know the bigger number has to be negative. So it'd be negative 8 and 5. So again, how does this relate to factoring? It's the whole first side of your assignment, the Snappy Factors, is training your brain to find numbers that multiply to one number, but add to another. So you can think, set up my framework first. I know because my first term is just an x squared. My first terms in the binomials have to be x. This is not always going to be the case, but when it is a trinomial with that first term as x squared, it fits this framework. If you can factor it, sometimes you can't. So what are two numbers that multiply to 21 but add to negative 22? Well, the first one I think of is 7 and 3. 7 times 3 is 21. It has to be negative, so negative 7, negative 3. Do not add to negative 22. So this is the kind of problem that usually stumps. Don't forget the 21 and 1. 21 times 1 is 21. It has to be negative. Negative 21 plus negative 1 is a negative 22. So those are my two end or last terms. Except I made that a plus, and I meant to make it a subtraction. So now I'm going to double check myself again. X times x is x squared. Negative 1x minus 21x is negative 22x. Negative 21 times a negative 1 is a positive 21. Check. We're all good there. All right, so this one down here is a little different. We still have the number 21, but now we have it as a negative, which means one of my numbers has to be negative. So I have my factors 7 and 3 and 21 and 1. One of them has to be negative. So it could be that, or it could be 21 and a negative 1. That. So we're going to add them together. We're looking for the difference of 4. Well, clearly it's not these, so it has to be one of these. So I'm going to set up my framework, and you can actually, for this part, the part that has all of the leading coefficients as 1, you can set up that framework for all of them. And then we needed that middle term to be negative, so we need the one that has more negatives. Negative 7 plus 3 is a negative 4, where 7 plus a negative 3 is a positive 4. So I know it's going to be this one. So I'm going to fill in x minus 7 times x plus 3. Always double check yourself. X times x is x squared, plus 3x minus 7x, that is a negative 4x minus 21. And before I end this, I want to remind you, just like the last assignment, you should, oh my goodness, those puppies, always look for a common, they must have a squirrel, a common binomial to factor out first. So if this had been, let's say, 2x and 8 and 42, you could have factored out that 2 first, so your answer would have looked like this. Thanks. I hope you learned a lot from this video, and I'm going to go figure out what my dogs are chasing after. Hannah, are you home? That's okay, I'm done. The dogs were being crazy anyway.
If you want, you can come upstairs and talk to me, Mom.
You don't like to talk to me. You said that I am stinky.
Okay.
Are you sure?